Hello, everyone. Welcome back to CPE 517-WS Digital and Computer Systems Architecture course. This is lecture 3, which is about instruction set architecture, and part 2, assembly code programs. So for assembly code program, we're going to use MIPS, which is also the basic instruction set we used for computer organization of the undergrad. So how we're going to do that? We're going to have to define first some containers for the opcode, operand, and then some opcodes, okay? So the container for opcode, operand are registers, memories, like a 4 GB memory, and then 32-bit general purpose registers, 32-bit floating point registers, high, low, and PC. PC is program counter, is a particular register for the execution of the program. It specifies the next program instruction, okay? And then some opcode. So we have arithmetic logic opcode, like add, unsigned, subtract, unsigned, logical operation of and, or, XOR, nor, set, less than. This is shown here. Set less than, unsigned. Add immediate value, add immediate unsigned value, set less than immediate, etc., etc. So many of them. So 4 of them. Then we have memory access, like load bytes, load word, store bytes, store word, jump instruction, branching instructions. For more details of the MIPS, you can click this green sheet, which I put it in my homepage. So basically, it specifies the data type, like it's immediate, unsigned. The format, it's like addressing modes. We're gonna talk about them later, okay? So here's the MIPS, right? So this is the instruction code or opcode, and then we have the 0 and 4 equals 4, right? Put it in as 0 register. And then this one add immediate of S0, $0, sorry. And then 1 and put it in $S1, which is another register. And then we do shift left by 2 of S1. And then we have a branch here. Say if branch equal, if S0 and S1 equals, we jump into the target branch, right? Because S0 is 4, S1 is 1. If we do left shift by 2, we got 4 as well. So S1 and S2 equal, then we jump to the target, to the execution of addition of S0 and S1 and put it in S1, right? So this execution and this execution is not executed. It has to be reminded that labels, like the target, indicate instruction locations in a program. They cannot use reserved words. Like reserved words are like as sub add I be equal to opcodes, or some assembly code is general purpose registers, and must be followed by a colon after this label, right? Okay. So here, this $0 is a 0 register. It's a register of a value 0. Okay. We talk about the branching, conditional branching, right? So is that if they equal, we jump to the branch, right? We also have the unconditional branching of direct jump. For example, we have this S0 equals 4, get 4 as 0, S1 as 1, and then we directly jump to target. No matter, there's no sort of comparison, right? So that means this code, 9 code will never be executed. And then in here, we do S0 and S1, add them together, and it's 5, put it in S1. So here, we can also use the instruction address, the address as the label to jump, right? So here, we have the address of the instruction of 0x00002000. So this is a hex value, right? So, and then we have the next one is another word is 4 bytes away. It's 00002004. We can say, okay, I want to jump to the address of 0x2010. So the address of 2010 is here. So we can directly jump here. Okay. And then let's talk a little bit about, we're talking about if statement or branching statement, and then let's go to for loops. The general form of a for loop is like this, right? So we have a for loop initialization, condition, loop operation, and the loop body, right? Initialization executes before the loop begins. Condition is tested at the beginning of each iteration, including the initialization stage. Loop operation executes at the end of each iteration, right? And loop body executes each time after the condition is met. Okay. For instance, if we have this instruction, int sum equals 0, int I, for I equals to 0, and I is not equal to 10, I equals to I plus 1, we do sum equals sum plus I. So we translate this into MIPS instruction. Let's see how it goes. So first, we set as I as sum, okay? S1, sorry, S1 as sum, and S0 as I. Then what we do is we first add I to 10, and then do comparison. Say if S0 equals to T0, see, because T0 is 10, it's not equal, then the branch is not taken. So we go to addition of sum plus I and put the result into sum. After we do this, at the end of the iteration, we add I by 1, right? S0 is I. And then we jump back to 4. In 4, we keep checking whether the condition is met until I equals to 10. So which means S0 and T0 equals to are equal. Then we jump to then. Notice that assembly tests for the opposite cases, like I equal to 10, then the test is in the right side of I is not equal to 10, right? Because when S0 and T0 equals, that means S0 is 10. So then we jump out. So this is how it goes, okay? We'll put it in another word. We can also use BEQ, be not equal, then not equal, we jump to the body, right? But actually, we think this is easier if we set when it is equal to 10, we jump out instead of not equal to 10, we jump in. I hope this makes sense to you. If you feel this is unclear, please definitely drop me an email or join the office hour and would be very happy to explain, okay? And then we've been discussing quite a bit of MIPS, but instructions which uses registers, okay? But actually in the RISC-V or common popular instruction sets architecture, there are also some addressing mode that goes directly to memory. For instance, we have a register based. So for instance, R3 add R4 and put it in R4, something like this, okay? Immediate means we have R4 add a value of 3 and put it in register 4. We have also displacement, which means we use R1's value as the address to access the memory, right? With offset of 100. So here we assume that 100 is hex value, okay? 0x because it is 0x, okay? And then register, so let me put it here, so it's 0x. This is also 0x. Register indirect means we use a register's value as the address to access the memory and then fetch the value from the memory and do addition with R4 and put the result into R4 again. R1 and R4 as indirect means we use R1's address plus R2 value and R2's value together as the address and then go to memory to fetch the value, do the addition. Direct or absolute means we use the address of this specific absolute value. Okay, this is 0x111001. And then indirect means we use the register's value to access memory and use the memory's value again to access memory, right? And then auto increment means we increment after we do the calculation. This is like I++ or I minus here. And then scaled means we first use register 2 as the base address, and then plus register 3 multiplies the scalar of D plus 100. So this scale is a specific value. We're gonna put it in, right? Okay, so with all this knowledge we discussed, please use 15 to 20 minutes to translate this MIPS assembly code into, this C language code into MIPS code. So we do a little bit of exercise, okay?